Hello everyone. In this video, we are going to derive the expressions for the mean and the variance of the Poisson distribution. Recall from the previous video, the mean and the variance of a Poisson random variable x both equal lambda, where lambda denotes the average number of occurrences in a given interval. And this lambda is the parameter of the Poisson PMF. Let's start with the mean. The expectation of x, where x follows a Poisson distribution, equals lambda. So start with the definition of the expectation of x, which is equals to the summation for all possible value of x for the expression x times p of x. For a Poisson distribution, the random variable x can take on values 0, 1, 2, up to infinity. So we start from x equals 0 to infinity, sum over the expression x times p of x. And the PMF of the Poisson distribution is given by e to the power minus lambda times lambda raised to the power x over x factorial. Consider the first term in the summation when x equals 0. The expression is simply 0. So we change the lower limit from x equals 0 to x equals 1. Next, we will consider the expression x over x factorial. Simplify this into the expression 1 over x minus 1 factorial. And then we will decompose the term lambda to the power x. Lambda to the power x equals lambda times lambda raised to the power x minus 1. And lambda is independent of x, so we factor that out. And then we will replace the expression x minus 1, both in the numerator and the denominator, by k. So set k equals x minus 1. We get lambda raised to the power k in the numerator, and in the denominator, we get k factorial. Not to forget to change the limit if necessary. Here, when x equals 1, k is 0. When x approaches infinity, k also approaches infinity. So we change the lower limit x equals 1 to k equals 0, and we get the last expression. And then the expression within the summation operators, this is the Poisson PMF. And we sum over the values of k from 0 to infinity. So this summation expressions is 1. And we get the expected value of x equals lambda, which is the mean of a Poisson distribution. Next, we move on to the variance of the Poisson distribution. The variance of x of a Poisson random variable equals lambda. First, we will obtain an expression for the expectation of x times x minus 1. The expectation of x times x minus 1 equals the expectation of x squared minus the expected value of x. We already obtained an expression for the expectation of x, which is lambda. So we can solve for the expression for the expectation of x squared, which is equals to the expectation of x times x minus 1 plus the expectation of x. Once we get the expression for the expectation of x squared, then we can get the variance. The variance of x equals the expectation of x squared minus the square of the expectation of x. Let's proceed with the expectation x times x minus 1. By definition, this is equals to the summation of x times x minus 1 and then times the PMF. Sum over x equals 0 to x approaching of infinity. Consider the first two terms in the series when x equals 0 and when x equals 1. The value of the first two terms are 0. So we change the lower limit, start from x equals 2 to infinity of this expression. Next, we simplified the terms x times x minus 1 over x factorial as 1 over x minus 2 factorial. And then we will decompose the expression lambda to the power x, decompose it into lambda squared times lambda raised to the power x minus 2, and we will factor the lambda square outside the summation operators because it is independent of x. Finally, we set k equals x minus 2, and then the lower limit x equals 2 is changed to k equals 0. And then in the numerator, lambda raised to the x minus 2, we get lambda raised to the power k, and in the denominator, we get k factorial. And notice that this is the Poisson PMF, and then we sum over all possible value of k. So the value of this summation must be 1. And we get the expectation of x times x minus 1 is lambda squared. And then we can get the expression for the expectation of x squared, which is equals to lambda squared, the first term, the expectation of x times x minus 1, and then plus the expectation of x. The expectation of x is lambda. So the expectation of x squared is lambda squared plus lambda. We can get the variance of x. The variance of x equals the expectation of x squared minus the square of the expectation of x. Simplify the expression, we get lambda. So this is the expression for the variance of the random variable that follows a Poisson distribution. The variance of x equals lambda. That's it for today's video. Thank you for watching. In the next video, we will talk about Poisson process.